Friends, welcome to my YouTube channel. I am Shlok Kulkarni, and in today's lecture we are going to dive into descent questions from Keith Williams' General Navigation book. I am going to solve all the questions together one by one, and I am also going to show you how to solve these questions along with explanations so that you not only get to understand how to answer this question but also get a quick revision along the way. So let's start with question number 1 first. At what approximate distance from the threshold would an aircraft intercept the glide path if aircraft height is 2500 feet and the ILS glide path angle is 3 degrees? So we have to calculate distance from the threshold where you are going to intercept the ILS glide path of 3 degrees. Okay, so let's say this is your runway. Okay, and this is your 3 degree glide path. 3 degree glide path with respect to the horizontal surface. With respect to the horizontal surface. Okay, 3 degree. Your aircraft is at height of 2500 feet. Your aircraft is at a height of 2500 feet. So this is 2500 feet vertical distance. Now 2500 feet is nothing but equal to 2500 divided by 6000, approximately 0.4 nautical miles. Okay, we have to calculate this horizontal distance from the threshold, ground distance. So the formula is, let's use trigonometry, tan theta opposite side divided by adjacent side. So tan of 3 degree opposite side of 0.4 nautical mile divided by adjacent side x. So x equals to 0.4 divided by tan 3. So tan 3 is equal to 0.05. X will be equal to 0.4 divided by tan 3, that is equal to approximately 7.6 nautical miles or 8 nautical miles. That means what? Aircraft is approximately 8 nautical miles from the threshold. Using 1 in 60 rule formula, what is the formula? Track error angle or any angle equals to distance of track divided by distance gone into 60. So angle is 3 degree. Distance of track is 0.4 nautical miles. Distance gone x multiplied by 60. So x equals to 0.4 nautical mile into 60 divided by 3. So x equals to 0.4 into 60 divided by 3, that is 8. Okay, so you get 8 nautical mile answer. So select that option which is closest to this 8 nautical miles value. Next. Convert 70 meters per second into knots. Now, we know that 1 knot equals to 0.515 meter per second. Okay, so 70 meters per second will be equal to how many knots? Cross multiply 70 meter per second divided by 0.515 meter per second. So 70 divided by 0.515 is 135.9 or approximately 136 knots. Question number 3. If there is a 10 knot increase in headwind, by what amount must the rate of descent be changed in order to maintain a glide slope of 3 degrees? Okay, or whatever glide slope. So, there is an increase in headwind component. There is an increase in headwind component. Now, let's consider this is your runway. Okay, this is your glide slope, 3 degree. Okay, 3 degree glide slope. Your aircraft is coming down for landing. Now, in this phase of flight, your aircraft will be at low power, okay, slow, true airspeed, Okay, slow through airspeed. The lift component will be little, right? Now in this scenario, if you get an increase of headwind, if you're faced with an increase in headwind component, what will happen? An increase in headwind component will, okay, headwind component will decrease your ground speed further. As it is, you're coming down at slow through airspeed. Now when the headwind component increases, your ground speed decreases. Decrease in ground speed. Nothing but the forward speed of your aircraft with respect to the ground. Okay. And now when decrease in ground speed happens, what will happen as a result? The aircraft will descend at a faster rate of descent towards the ground. Okay. So whenever there is a headwind component or increase in headwind component, the rate of descent will increase. The rate of descent will increase. What are the important factors? Why does it happen? Because your aircraft engine is running at low power. Your aircraft true airspeed is very slow. Ground airspeed is further reduced by increase in headwind component. Okay, so these all factors combine to increase your rate of descent. In tailwind, the opposite happens. Whenever there is increase in tailwind component, the aircraft's rate of descent will decrease. Okay, it will slow down. You will come down towards the ground at a slower rate. But in increase in headwind component, your rate of descent will increase. That means you will come down towards the ground at a faster rate. Okay, so this is the problem. So when there is an increase in headwind component, you will come down towards the ground at a faster rate of descent. So this is a problem. Okay, this is a challenge. What is the solution to this problem? The solution to this problem will be to increase. Solution will be to your engine, increase your engine power. Okay, to increase your engine power. When you increase your engine power, the true airspeed of your aircraft will increase. As a result, the ground speed will also increase, or at least you will try to maintain it. Okay, and this way you will be able you will be able to maintain degree glide slope. Okay, if you don't apply these solutions instantly, whenever there is an increase in headwind component, you will not be able to maintain this 3-degree glide slope down to the runway. Okay, you will undershoot the runway because the headwind component or increase in headwind component results in increase in rate of descent. Okay, so the solution will be to increase your engine power. TAS will increase, ground speed will increase, you will be able to maintain your 3-degree glide slope. So, finally, final results or final conclusion, headwind component increases your rate of descent. Okay, it increases your rate of descent. As a pilot, you must decrease your rate of descent, decrease your rate of descent, or do whatever is required to maintain your to maintain your initial rate of descent. So if you have flown during your CPL training, you must be familiar with this concept because all through our training, we are faced with headwind components, increase in headwind components, crosswind components. So we know practical application of this knowledge or of this concept. If you haven't flown any hours, so whenever you start flying, you will notice this. You will definitely experience this lesson, experience this concept in the air. So you will remember it like that. Okay, but this is what it is. Now, if there is a 10 knot increase in headwind, by what amount must the rate of descent be changed? So the formula is rate of descent, change in rate of descent equals to 5 times change in ground speed. 5 times change in ground speed. So what is change in ground speed? So when there will be 10 knot increase in headwind, so what will happen to our ground speed? Our ground speed will decrease by 10 knots. Correct? Increased headwind increases. As a result, what will happen to our ground speed? Ground speed decreases. Okay. Headwind decreases. Headwind component decreases, reduces. Your ground speed will automatically increase. A decrease in headwind is nothing but increase in tailwind component. Can be interpreted or translated as increase in tailwind. So other way around. So 5 into change in speed, 10 knots. So 5 into 10, that is 50 feet per minute. So the rate of descent must be changed by 50 feet per minute. More specifically, more specifically, the rate of descent must be decreased by 50 feet per minute, minus 50 feet per minute. Okay, next. What will be the rate of descent when flying down a 12% glide slope at a speed of 540 knots? Now, usually glide slopes are measured in terms of angular degrees. Now, it can also be interpreted or expressed in the form of percentages, slope. Okay, so we can convert this 12% glide slope into corresponding angular measurement. How? Slope equals to tan theta, where theta is the angular measurement, multiplied by 100. So 12% equals to tan of theta into 100. So tan theta will be cross multiply 12 divided by 100, which is equal to 0.12. So theta will be equal to tan inverse 0.12, which is shift tan inverse 0.12 is 6.8. So approximately 7 degrees. So the glide slope is very steep, 7 degrees. And now ground speed is 540 knots. Rate of descent, step 2, rate of descent equals to speed in terms of feet per minute multiplied by slope divided by 60. So what is the speed given in the question? It's 540 knots. Be careful, it's 540 knots. So convert it into corresponding feet per minute by multiplying it by 101.3. 1 knot equals to 101.3 or approximately 100 feet per minute. Okay? So divided by 60. And slope is what? 540 into 1013 into slope 7 degrees. So 7 into 540 into 101.3, 382,914 divided by 60 is 6381.9 or approximately 6382 feet per minute. So rate of descent is 6382 feet per minute. So select that option which is closest to this value. Next, aircraft flying down a 3-degree glide slope is 25 miles away from the threshold. Using the 1 in 60 rule at approximation of 1 miles equals to 6,000 feet, calculate aircraft height above the runway threshold, assuming that the ILS glide path crosses the threshold at a height of 50 feet. Okay, so this is your runway. This is the horizontal datum. Okay, your glide path, 3-degree glide path is something like this. Okay, it passes. This is the threshold of your runway. This is the threshold of your runway, and this glide slope passes the threshold of the runway at a height of 50 feet. At a height of 50 feet. Okay. Now your aircraft is going to follow this glide slope, correct? So whenever aircraft fly, so as aircraft follows this glide slope and glides down towards the runway, it will be at height of 50 feet above the threshold of the runway. Okay, and it will follow this glide slope down to the touchdown zone of the runway. Okay, so when this aircraft flies along this glide slope, it will be at a height of 50 feet above the threshold. So the measurement, so we will have to draw another triangle like this. Okay, so aircraft is at 25 miles from the threshold. Calculate the aircraft height above the runway threshold. So this is 25 nautical miles away from the threshold. This is 3-degree glide slope. We have to calculate aircraft height. Now we will have two types of aircraft height. One height of aircraft with respect to the glide slope datum, okay, which is this. And second, height of aircraft with respect to the ground surface, that is at the level of the runway. So first we will find out the aircraft height with respect to this glide slope datum at 50 feet above the runway threshold. Okay, so that will be x. So what is the formula? Tan theta equals to opposite upon adjacent. So tan 3-degree opposite is x. Adjacent side is 25 nautical mile. Convert that into feet because aircraft height is in terms of feet. So x will be tan 3 into 6000 into 25, that is 7861. Okay, 7861 feet. So that means aircraft is 7861 feet above the threshold of the runway. Okay, and when you add the threshold of the runway to this aircraft height of 7861 feet, you will get, next answer will be aircraft height is 7861 above the threshold of the runway plus extra 50 feet, which is the height of the glide slope with respect to the threshold. 7861 plus 50 is equal to 7911. That is 7910 approximately feet. So that means aircraft is at a total height of 7910 feet from the ground surface. Now let's use 1 in 60 rule formula, which states that angle equals to distance off track into 60 divided by distance gone. So 3-degree equals to distance off track unknown to us x, distance gone 25 nautical miles into 60. So distance off track, that is aircraft height with respect to the threshold, with respect to the glide slope, which is 50 feet above the threshold, is 3 into 25 miles multiplied by 6000 feet divided by 60. So x will be equal to 3 into 25 into 6000 divided by 60, that is 7500 feet. Okay, so using tan theta formula, we got the value of 7861. Using 1 in 60 rule formula, we have got a value of 7500. Okay, so this is the height of aircraft with respect to the glide slope, which is 50 feet above the threshold. Now, total aircraft height above the runway threshold will be equal to 7500 plus 50, right? So 7550 feet. So you are going to select that option which is closest to either of these two values, 7,900, 7,550. Okay. Now here they have asked you to use 1 in 60 rule. Okay, so use 1 in 60 rule formula and use or select that option which is closest to this 7,550 value. Next, 730 feet per minute equals to how many meter per second? So 1 knot equals to 101.3 feet per minute. So 730 feet per minute will be equal to how many knots? Cross multiply 730 divided by 101.3. So 730, 101.3 is 7.2 knots. Step number 2, 1 knot equals to 0.515 meter per second. So 7.2 knots will be equal to how many meter per second? Cross multiply 0.515 into 7.2. So that is equal to 3.7 meter per second. So select that option which is closest to this value, 3.7. A 15 knot increase in headwind. Again, an increase in headwind is given to us. By what amount must rate of descent be changed in order to maintain 3-degree glide slope? Okay, so we know that whenever there is an increase in headwind, we must decrease our rate of descent deliberately. Okay, so change in rate of descent equals to 5 multiplied by change in ground speed. So 5 multiplied by, if there is 15 knot increase in headwind, the consequence of it will be that there will be 15 knot decrease in ground speed. So 5 into 15. So 5 5s are 75. So the change in rate of descent required is 75 feet per minute. Namely, you must decrease your rate of descent. Aircraft must decrease rate of descent by 75 feet per minute. Okay, minus 75 feet per minute. 10-degree glide slope and speed of 500 knots. What is rate of descent? So rate of descent is again slope multiplied by speed in terms of feet per minute divided by 60. Slope 10 degree, speed 500 knots. So 101.3 divided by 60. So 10 into 500 into 101.3 divided by 60. 8,441. 8,441 feet per minute. Okay. Next. Aircraft is at flight level 370, 100 nautical miles from a station. It has to arrive over that station at flight level 120. Ground speed is 396. What is the rate of descent? So, let's say there is a DME station here. Okay. Aircraft is in the atmosphere at flight level 370. Flight level 370. The DME station is at flight level 120, meaning aircraft has to arrive or has to descend from a level of 370, 37,000 feet to a level of flight level 120, that is 12,000 feet. That means when it arrives over DME station, it should be or it must be at a height or level of 12,000 feet. Okay, so it is 100 miles away from this station. So it is 100 miles away from this station. What is the rate of descent? So rate of descent equals to how many feet you are going to descend. Okay, that is the change in your vertical distance, change in level, how many feet you are going to descend, or how much, or what is the change you are going to bring from descending from a higher level to a lower level, the change. Okay, divided by time in minutes. Time in minutes, and the change in levels will be in terms of feet. So the final SI unit will be rate of descent equals to feet per minute. So first step, step number 1, the change in level. So what is the change in height or change in level here? 30, you're descending from 37,000 feet to 12,000 feet, affecting a total change of 37,000 minus 12,000, 25,000 feet. Okay, so let's write it here, 25,000 feet. Now time. To find out time in terms of minutes, we will have to use speed distance time formula. Speed is 396 knots. Speed is 396. Distance is 100 nautical miles. So time will be equal to distance divided by speed, 100 divided by 396. So that is equal to 15 minutes. 15 minutes. So write it here. Now 25,000 divided by 15 is 1666. So rate of descent is equal to 1666 or approximately 1670 feet per minute. Okay, so this is the answer. Select that value or that option which has a value which is closest to this number. Question number 10. Aircraft is descending down a 12% glide slope, maintaining a speed of 540 knots. The rate of descent is approximately how much? So step 1, convert this glide slope in terms of percentage into corresponding angular measurement. So slope is equal to slope equals to tan theta into 100. So 12% equals to tan theta into 100. So tan theta is equal to 12 divided by 100, that is 0.12. So theta, that is angular measurement, will be equal to tan of inverse 0.12. So shift tan inverse 0.12 is 6.8 degrees or approximately 7 degrees. Next, rate of descent in terms of feet per minute is slope in degrees multiplied by speed in terms of feet per minute divided by 60. So 7 degree into speed. What is the ground speed? 540 knots. So 540 into 101.3 feet per minute divided by 60. Okay. So 7 into 540 into 101.3 divided by 60 is 6381.9. 6382 feet per minute. Select that option which has any value, which has a value closest to this, 6382, 6380, whatever. Okay, so right then we have solved a total of first 10 questions from this chapter, descent chapter in Keith Williams 10. I suggest you all to practice this 10 questions again without looking. If you encounter any doubt, questions, let me know in the comment box of this video. If you find this lecture very helpful, do hit the like button, subscribe to this channel and share this video lecture with your friends. It might help them in their exams also. In my next video lecture, I will do the next 10 questions, so don't miss that.